Hello there, my name is Musa and I welcome you to this video. In this video, we will be discussing homogeneity of a function. We will show how to determine if a function is homogeneous. Hope you found this video beneficial. If you do, please leave it a like and subscribe to the channel. So let's start. How do we determine if a function is homogeneous and of what degree? As you can see, we have written out the definition of homogeneity, but I think the best way to explain is with an example. So, first example, given y equals a function of x and z. If y equals x plus z, determine if the function is homogeneous and of what degree. Solution. So the function is y equals x plus z. To determine if this function is homogeneous or not, the first thing we have to do is that we have to introduce a scalar into it or a multiplier. This is what we mean. We know that y equals a function of x and z. So y equals a function of x and z. But we are going to introduce a scalar or a multiplier into it. So the multiplier we're going to introduce, let's use lambda with the x variable x, comma, take the same multiplier again, lambda, multiply it with the variable z. So this function went from this to this. Now, what is the purpose of expressing the equation in this form? The goal is we have to remove the multiplier and end up with this. If we remove the multiplier from this equation, if we remove the multiplier from this function, we have to end up with the multiplier, which is lambda, times the function given to us in the question. We have to end up with this. So if we're able to end up with this, after removing the multiplier, if we're able to end up with this function given to us in the question, then the function is homogeneous. If we are unable to get the function back after removing the multiplier, then the function is not homogeneous. Now, let's see if this function is homogeneous or not, and of what degree. The question gave us y is a function of x, comma z, and that's equal to x plus z. So if we are to apply this, that means y will be equal to f into the multiplier lambda x, comma, the multiplier z. That's equal to, that means anywhere we see x in the function, we replace it with lambda x. So we'll have lambda x plus, and anywhere we see z in the function, we'll replace it with lambda z. Lambda z. The goal now is to remove this lambda from the equation. So if we are to remove lambda from this equation, we have f of lambda x, comma, lambda z equals, when we factorize, we remove lambda out, we are left with x inside plus z inside. Once we have removed this, the lambda is out, the multiplier is out. So that means we have achieved what we are trying to get, which is this here, to remove the scalar out of the equation. So now let's confirm if this function is homogeneous or not. So f of lambda x, comma, lambda z equals the multiplier, which is lambda. It is indeed multiplied by x plus z. Remember, the question said y equals x plus z. And x plus z is this function here. So that means f of x, comma, z. So after removing the lambda, which is the multiplier, we got back the original function. Hence, we can say this function is homogeneous. Now we need to determine the degree of homogeneity. So this function is homogeneous of degree. How do we determine the degree of homogeneity? Let's go back to this here. We said if after removing the multiplier in this situation, which is lambda, we need to check for the power the lambda is carrying, the power of the lambda. So when we go back here, we see that the power of this lambda here is 1. So that means this function is homogeneous of degree 1. And that's it. Another example, f of x, comma, y equals x times y plus x square. To determine if this function is homogeneous or not, homogeneity holds if f of, we introduce a multiplier, lambda times x, comma, the lambda times the y is equal to, we removed the multiplier, multiplied by the function in of itself, which is x, comma, y. If we introduce this multiplier into the function, and we remove the multiplier from the function, and we are left with the multiplier times the function, then that means the function is homogeneous. So from f of x, comma, y equals to xy plus x square, that means f of lambda x, comma, lambda y equals, so we go and substitute lambda x. Anywhere we see x in the function here, we substitute lambda x. So that means lambda x multiplied by lambda y plus lambda x all square. So the function originally was x times y plus x square. But instead of writing x, we replace it with lambda x. Instead of writing y, we replace it with lambda y plus, instead of writing x square, we replace it with lambda x all square. So now the goal is to remove lambda from this equation. So to remove lambda from this first part here, that will be lambda, because we have two lambdas here. So that will be lambda square multiplied by x, y plus, remove lambda from this second part here, we will have lambda square x square. So when you open it back, lambda square times xy will give you lambda x lambda y, of course. So that will be equal to, that means f of lambda x, comma, lambda y equals to this. So f of lambda x, comma, lambda y equals, now we have lambda square xy plus lambda square x square. Let's factorize it. We will have lambda square x y plus x square. So with factorization, we can see that after removing the multiplier, we have the equation back again. So that is f of lambda x, comma, lambda y equals the multiplier, which is lambda square, is multiplied by the function given to us in the question, which is xy plus x square. So we have the original function f of x, comma, y. So we can say this function is homogeneous of degree. To determine the degree of homogeneity, we said we simply go to the multiplier, in this case the lambda. What is the power? The lambda here is having a power of 2, so square. So homogeneity of degree 2, and that's it. Homogeneity of a function can also be confirmed with the use of Euler's theorem. To determine if homogeneity of the function holds or not. You may refer to the video at the top here to see how Euler's theorem is used to prove the homogeneity or to confirm the homogeneity of a function of a certain degree. Thank you very much for watching. Hope you found this video helpful. Please leave a like and subscribe to the channel. See you in another video.